Okay, today we're going to continue talking about correlation, but we're going to talk about the correlation coefficient and what that actually means and how to use the data to get the line of regression or the trend line or the line of best fit. Yesterday, we just estimated and drew a line that looked like it could be the best line. However, today we're going to learn how to actually get that line. Okay, so on your foldable, okay, fold it, glue this side down, and so on this front side, okay, the vocabulary we learned yesterday is correlation. So correlation is the relationship between two variables. So we're going to be, like I said, talking about that again today. So look at these two scatter plots. Here we've got scatter plot A and scatter plot B. Both have what kind of correlation? Well, this is what we talked about yesterday. So both of these have a positive correlation because they're both going in an upward direction. These points are. Okay. Which one do you think has a stronger correlation and why? So think about that for a second. Which one do you think is stronger? If you said plot A, then you're correct. Okay? Because the dots are closer. Okay? So the closer that your data points are together, okay, the more that it looks like an actual line, then the stronger correlation that it is. So that's what we're going to be talking about today. Okay? And we have this thing called a correlation coefficient. Okay? It's represented by the letter R. Okay? It is a number ranging from, it's a number ranging from 1 or -1 to 1 that measures how closely related a data set is. It measures how well the line of best fit represents the data. If R is near 1, then there is a positive correlation that is strong. If R is near -1, then there is a negative correlation that is strong. The closer R is to 0, the weaker the correlation. Okay. So I think of these as a negative 100% and a positive 100%. Okay, so and then of course a 0%, right? And we know that the closer a percentage is to 0, the worse a grade it is, right? Okay, so it's a stronger grade if it's close to 100%. Right, so strong negative correlation is going to be over here near the -1. Strong positive correlation is going to be over here near the +1. Okay. Now, I have a video for you to watch and follow along, showing you how to figure out what the R is and the line of best fit using the classroom calculator. And then I'm going to do one showing you how to do it on Desmos. Okay, so here's the video that you need to, that we're going to watch.
Hey, so you want to learn about linear regression? Well, came to the right place. First, we need a list. So let's add a page and let's go to add a list. You need to name your first list. I'm going to call it L1. You can call whatever you want. Avoid X, avoid Y. Trust me. Let's do 1, 2, 3, 4, 5, 6 for L1. And then you got to label the second list L2 or something else of your liking. Let's say this is 9 and 19 and 25 and 44, 51, and let's go with 63. That's not 63, 63. All right, we got our two lists made. Now we want to create there's two ways of doing this. One is to create a scatter plot. That's the first one I'm going to show you. And so you need to add a new page. So Control, add a page. We're going to go to Data in Statistics. And that looks similar to a scatter plot, but these points are just kind of randomly thrown around. You can use your little touchpad thing here, swipe it, go down there, click to add a variable. We're going to choose L1 for this one, and then whoop, and then we're going to go click this guy and do L2, and look at that scatter plot. Beautiful. Now we want to add a line of best fit or do the linear regression. So I'm going to hit Menu, and I'm going to go to Analyze and Regression, and I'm going to do linear regression, but if you wanted to do like a quadratic regression or some other kind of regression, you can choose that in this window. Let's show linear regression. There it is, and it's great. And that says the equation of your linear regression line. If you don't have enough decimal places here, note you can also hit Menu and go to Settings and then change it to the amount of decimals that you want here under Settings, because sometimes the default, I think, is only 1 or 2. It's not a lot. And that is pretty much it for that window. Another way of doing this is if you go back to just a calculator window. Now I've already got my L1 and L2 in there. If you don't believe me, hit L1. There it is. Hit L2. There it is. Another place to find it is go under variables, hit bar. You'll see L1 and L2 also live there. So my lists are in there. Once you do it in one page, it's going to be in another page. So you're all good. And I'm going to go to Menu, Statistics, and the first one, Stat Calcs, and then I'm going to do linear regression. Hit it right there. My first list for X is going to be L1. My second list is going to be L2. It's going to save it to F1 if you want the line actually saved somewhere to use it later on. And then you just hit OK, and there it is. There's M, your slope. There's your y-intercept. There is R squared, the coefficient of determination if you need that. And there is your R, your correlation coefficient. And that's all there is to it. So enjoy. I hope you have fun. Go ahead and find the linear regression of like everything you can, because one.
Okay. This right here, guys, will give you the slope and the y-intercept, excuse me, for any of the anything. So like if you're given 2 points and asked to find what the line is for those 2 points, you can do this. Put it in. You just have to have 2 points, and it'll figure out your slope. It'll figure out your y-intercept, and then you have your linear equation. It will do the same thing for a quadratic. Okay, quadratic regression will do the same thing. It will give you your A and your equation, so you can play around with that, because on the star, if you're given information, a table and whatever, and asked to figure out what the formula is for the quadratic formula, or the quadratic equation, or an exponential equation, or whatever, this regression works for all of those. You just have to pick the right one in the list, like he showed you before.
Why not? I guess it's time to go celebrate Inktober. I'm going to go get a tattoo by Howie. Bye.
Okay, so the steps that he gave you to do is create a spreadsheet, label your columns at the top, okay? Put in your data, and then select menu, stats, linear regression, okay? I think I missed putting in here that he added a new page, so add page, okay, in order to get that information. You can also do the scatter plot like he showed you and whatever, but to get the information you need, you don't necessarily have to do the scatter plot. So you just need to do the linear regression on the thing. Okay? So now I'm going to show you how to do it using this data. Okay, that's actually part of our foldable using Desmos. Okay. Okay, now that you've seen how to get the linear regression and the line of best fit using the classroom calculator on the YouTube video that I had to find because I don't have a way to show you here at the house because I don't have the calculator on my computer at home. So anyway, now I'm going to show you how to do it in Desmo. So we're going to use the actual handout, the foldable that you have to work it out. So in Desmos, you are going to use X and Y. And you're going to add a table. Okay, so X1 and Y1. So your X values will be right there from the list. So we've got 3, 7, 10, 15, 18, and 21. Okay. Then I'm going to go over to the Y values and I'm going to type them in. So 17. Okay. Nope. Keyboard. Missing. So 17. 46. 84. I don't know why it gets a break when I hit enter on this side, but anyway. 103. 117. And 201. But we don't want this extra line, so we want to backspace it. Okay. So if you'll notice, okay, we can't really see our dots because I need my data here to be different so I can see all my points on here. So I'm going to change my settings on the Desmos graph. So notice that my x's start at 3 and go to 21. So I'm going to change this to a -5, just like, and we'll do 30. And then on the y-axis, I'm going to change it as well. Notice it starts at the lowest is 17 and it goes to 201. So I'll just start it at 0 and have it go to 225. And now I should be able to see my dots. Should be able to see the pattern there and what it looks like. So you should be able to see that this looks like a positive correlation, right? It looks like it's going up, positive direction. Okay? So to get it to give us the same data that you could get on the handheld calculator from the classroom, you have to actually type it in here. There's not a menu that you can go to, so you have to memorize this. Whereas on the classroom calculator, you don't have to memorize anything to put in, you just have to memorize the steps. So there's the difference, because you can use this on the star, but you have to remember how to do it and type it in. So we're going to type it in just like our So y1, okay, equals, oh, not equals, sorry, we got to use the little squiggle because we want it to approximate for us what the equation is going to be. So y1, and then we're going to type in our m, okay, and then x1, because those are our, what we have in our table is y1 and x, or x1 and y1, okay, and then we're going to do plus b, because that's our linear equation that we like to use, our slope-intercept form, y equals mx plus b. So we're telling the calculator, the Desmos, to give us the information we need. So if you will notice, down here, okay, here, okay, is the slope. Okay, here's the y-intercept. So if I needed to write the equation for this line, I would say y equals 8.85 x, okay, that's my slope. My m is right there in front of my x, okay, plus b, or minus 14.61. Okay? So there is my equation for my line of best fit using the slope and the y-intercept that I've been given. Okay? It also gives me my r. Okay? I don't care about the r squared. That's not what I'm looking for. We don't deal with that in Algebra 1. We just need the r, which is the correlation coefficient. Okay? And so this, which we're going to talk about today, and we think that this tells me that it has a 95% correlation. Okay? So think of it just like you do grades and whatever. That decimal translates to 95%. This is a strong, okay, correlation. Strong positive, to be specific. Okay? So this is how you would do it on Desmos and get Desmos to give you the same thing. You just have to remember to type this in to give it, to get it to do it for you. All right, so now over here on our foldable, the line of best fit would be y. Okay, y equals 8.85x plus, nope, actually not plus, minus 14.61. Okay, so there's the line of best fit. The correlation coefficient is the r, and r equals 0.95. Okay, so that's how that you would do that. So now we're going to, so now here's the steps in Desmos. So create a table, enter the data, and then type y with the little squiggle, m, so y1, because that's what your table's automatically going to have, the little squiggle, m, x1 plus b. This little squiggle that's right here, okay, it's found on the Desmos keyboard, so you can use the Desmos keyboard, or it's found on your actual keyboard of the Chromebook right next to the number 1. So like you shift and then that symbol is right there next to the number 1 on your keyboard. Okay? So now, let's talk about this next part right here. Okay? It says, below is a list of correlation coefficients from multiple sets of data. Put them in order from strongest to weakest. Okay? So, strongest to weakest. Doesn't say anything about negative and positive. Okay, strongest to weakest. So we're going to start out with the strongest, okay, which is anything that's closest to 1 or negative 1. Okay, so this one is going to be my strongest. So 0.875. Okay, that's my first one. And then my next one is going to be this one. Even though it's negative, it's still my next strongest. So 0. Goodness. Pin. 0.567. Okay. Then my next strongest is going to be this one. Okay, negative 0.232. The next strongest, this one's going to be close. Okay, we've got this one, and we've got this one right here. Well, the 8 is going to be stronger than the 6, okay, because it's going to be a little bit closer to 1, so 0.158, and then negative 0.156. And then the weakest one is going to be 0.006. My pen does not want to work for me today. Okay, so that's listed from strongest to weakest. When you're doing strongest to weakest, the negative does not matter. The negative just tells you how the correlation is strong or weak. If it's a strong negative or a strong positive correlation. But strength-wise, you only care about the numbers, not the symbol, or not the sign, positive or negative. Okay, so now we've got this example here. Use the data in the table below to answer the following questions. Round to the thousandth place. Okay. So I'm going to pause it right here, and we're going to go, and I'm going to let you put this information in Desmos on your own for a second. Okay, give you some time to do that, and get the information in Desmos or on your calculator from the classroom. Either one will work fine. Okay. So work it out. Okay. You should have had a chance to put this information in Desmos and worked it out. And so your line of best fit so far is y equals 18.039. Notice I went to 3 decimal points this time because it tells me up here to go to the thousandths place. That means 3 decimal places. Okay, plus 20.314. Okay, again, thousandths place, so 3 decimal places. Same thing with the correlation coefficient. I went 3 decimal places because it said to round to the thousandth. Okay, so my R is 0.994. Okay, it is a strong positive correlation. You could actually say very strong because it is very, very close to being at 1. It's like a 99%. Okay, so it's very close to being 100%. Mm-hmm. Then question D here says, using the data, predict the y value when the x value is 10.5. Okay, so we're going to substitute in 10.5 to my x value in my formula that I came up with. Okay. So y equals 18.039 times 10.5 plus 20.314. It is a 4, not a y. Okay. So when I put that in my calculator, I get the answer 209.724. So y equals 209.724. I'm sorry that my pen does not want to work, guys. Okay. Then the next one says, using the data, predict the y value when the x value is 0.25. And do the same thing. So y equals 18.039 times 0.25 plus 20.314. Word, guys. So y equals, in this case, 24 point, 24.824. Okay. So there's how you figure out your line of best fit and your correlation coefficient, and also predicting data for x values given. So now you have a boom assignment to work on as well, to figure out your line of best fit, and one to deal with your correlation coefficient. So good luck and get started.